Geomorphology is the scientific study of landforms, their causes, and their change. On the Earth's surface, there are different orders of landform. First order landform is continent and ocean basin. Then, second order landform are found separately on continents and in ocean basins. This way, there are some micro landforms, some meso, and some micro. Micro landforms are of short duration and they are like distributaries, knick point, and morenic deposit. Now let us study the main topographical relief features found on the continent. As there are different features or say relief features on our face like nose, forehead, cheek. In the same way, on the continents there are different topographic features. Let us study this. Here you are seeing this model in which this is a mountain, this is a plateau land, and this is a plain, and this is sea level. Sea level or this is mean sea level, and there is one datum plane. Datum plane is an imaginary line drawn at the level of sea level. For example, if we cut the India at the level of sea or water level, sea level here at Kanyakumari, if we cut with a very sharp knife at datum plane or sea level and take away the Indian peninsula, then you will get a very flat surface, that is imaginary plane, and that is called datum plane. Plane spelling P-L-A-N-E, not P-L-A-I-N. If on datum plane you will roll down a ball, it will smoothly and uninterruptedly move ahead. Contrary to it, on plane, ball will be hindered by some mounds or some rivers because it has some rugged surface. Now, what is difference between plain, plateau, and mountain? Let us take criteria one by one. First criteria of differentiation is height from sea level or datum plane. If the height of a land or continental part is 100 meter and below, this is termed as plain. And second point is the plains are having rolling ground, rolling surface, and plains are mostly formed by different rivers. In world there are different plains like plains formed by Mississippi, Missouri in North America, Amazon, Parana, Paraguay in South America, Nile, Congo in Africa, and Indus in Pakistan, Ganges, Brahmaputra in India, Murray Darling in Australia. This way you can locate the plains formed by the rivers on the world map. And there are a number of rivers which are smaller than these, which have also developed plain. Here you should keep one point in mind that the plain, this is P-L-A-I-N, not P-L-A-N-E. The plain is of two types, one erosional, second depositional. In upper part, the rainwater or the surface runoff causes erosion through sheet erosion, rill gully erosion. This is erosional surface, wherein sometimes hard rocks are visible. This material brought down by rivers deposited in the lower parts at the mouth of river or near the sea level, which is also called delta. This is termed depositional plain. In the division cycle of erosion, we will go in depth in erosional plains, how they are developed. And now the second topography is plateau. With reference to height, the height of plateau is between 150 meter to 600 meter. Means the height of plateau is below 600 meters. But there are some exceptions also. For example, the height of Tibetan plateau is about 5000 meters or 5 kilometers from the sea level or datum plane. Why? It has some tectonic causes. We will study it in the geophysics or plate tectonics of India. When Indian plate moved northward, its northern margin subducted below Tethys Ocean, and the northern part made pressure on below the Tibetan plateau, with the result Tibetan plateau was raised exceptionally. That's why its height is more than the defined. Now let us define mountain. If the height of a surface or topography is more than 600 meters, this is termed mountain. Now take the example of Himalayan range or Himalayan mountain. This is Greater Himalayan range. Keep in mind, I am saying range. This is Middle Himalayan range. This is Shivalik Himalayan range. And Greater Himalayan range has some peak and pass. Its top is not flat topped. Why? Because at the time of formation, when it came out of geosyncline, Tethys geosyncline, there was differential force in tectonic. That's why some part was raised, called peak, and some was not so raised, it was called pass. Now if somebody wants to travel from China to India, question is, he or she will come through this peak or this pass. Answer is very easy, from pass. Likewise, rivers also starting from Tibet plateau and coming towards India follow the pass. And rivers continuously erode deep their valleys, hence gorges are found, and such rivers are called antecedent. How? This will be discussed in the Himalayan in detail. This is Middle Himalayas having also peak and pass. Now the question is that between Greater Himalayas and Middle Himalayas there is a valley like Kashmir Valley, Kullu, Manali Valley, and to the south of this Middle Himalayas there is Doon. Doon is also a type of valley, but India locally called Doon. Like Dehra is the largest Doon in India, and other Doons are Kotadyur, etc. To the south of this Doon, now this is Shivalik range, and Shivalik has also peak and pass, but of a smaller size due to less tectonic force. So these are the three ranges: Greater Himalayas, Middle Himalayas, and Shivalik Himalayas. Now one question is, you have to develop one tourist spot as a hill station or at a hill station. So hill stations will be established on these peaks, not in valleys, not in pass. So which range would you prefer for the development of tourist spot or hill stations? If you will go on the Greater Himalayas, that is not suitable because this is ice capped. So better to develop hill stations on the peaks of Middle Himalayas, because Shivalik will also not be suitable for the development of tourist spot because of very high temperature during summer season because of its closeness or proximity with the Gangetic plain, where temperature rises up to 40 degrees Celsius or more. Now, you have very clear concept what is range. These are the ranges: Greater Himalayas, Middle Himalayas and Shivalik Himalayas. And at the foot of mountain where plateau starts, or plain may also start in some conditions, the material or boulders, round-shaped stones rolled down by rivers are deposited here at the foothill of mountain, and this is called foothill of mountain or Bhabhar area. Bhabhar has a number of landforms like alluvial fan, alluvial cone that will be discussed in fluvial process. Now, you will keep in mind that sometimes at the foothill of mountain there is no plateau, rather rightly there is plain. For example, in India, if you go in UP Tarai or Bihar Tarai, just after plain or Tarai region, there is Bhabhar foothill, and to its exact north, mountain starts like Shivalik. So, that will be discussed in India in detail, and this plateau is called foothill plateau. Now, one thing that you are expected to answer, that the composition of these or the rock or structure of these differs. What is difference between the structure or geology of these three relief features or topography? It is clear that here this is plain. The structure or geology of plain will consist of alluvial depositions. That alluvial may be older and newer. In older alluvium, you may get mound of conker pan. You might have seen in villages in the Uttar Pradesh. And here plateau land is not made up of alluvial deposit. Rather, plateau are the part of Pangea. Pangea was broken in two parts by endogenic forces. Northern part Angara land and the southern part Gondwana land. Endogenic force did not leave Angara and Gondwana land, rather broke them again. That's why a number of plateaux came into existence like Canadian plateau, Brazil plateau, Patagonia plateau, Siberian plateau, Deccan plateau. Africa is largely consists of plateau. That's why a number of plateaux came into existence. One exercise with you, that you will draw a world map and locate all the plateaux. And if you will bring those plateaux together, you will construct Angara land, Gondwana land and Pangea. So these are plateaux of very hard rock, and these are minerally rich also. The rocks making these plateaux are mostly igneous and metamorphosed and hard sedimentary. Now, regarding the mountain, geology is very soft because this is folded structure. Rocks are sedimentary. So, on the basis of height, you can demarcate it. On the basis of structure, geology, you can differentiate. And there may be one question that what is the economic value of these three topography or relief features? So, if question is there that which is suitable agriculturally, answer is clear. This plain land is suitable agriculturally because soil is also good, deep and humus rich. Second question is, which of the three will be rich in mineral resources? it is very evident that minerals were formed in geological past. Why? Due to very high pressure and due to high pressure and high temperature. And at that time, earth was getting cooled, rocks were formed, and some precious minerals like gold, diamond, these are also rocks in geological terms, they were also formed. So, all the precious minerals are today mined and they are found in the plateau land area. What is the importance of this? If the question is which is suitable for tourism, so in world these are the mountains suitable for tourism, where coniferous and mild grass will be found in the mountainous region. One thing to keep in mind is, sometimes question is there, what is difference between mountain range, mountain chain and mountain system? So you can write, you may be expected to write 100 words on the difference between mountain system, mountain chain and mountain range. Now mountain range is clear to you that Himalayan region is a mountain chain. In one mountain chain there are 3 mountain ranges separate, and Greater Himalaya is a mountain range, Middle is independent range, Shivalik is independent range. But if we take these 3 collectively, that is called mountain chain. Now, if there is Vindhyan mountain, so that is chain or range, you can answer. That is range. Appalachian is a range. Aravalli is a range. Satpura is a range. If that is one independent line, so that is called range. If there are more than 1, 2, 3, that is collectively called chain. For example, if you take Rockies and Andes mountain, like Himalayas, they also have 3 ranges. And in Latin language, mountains are called cordillera. So in North America Rockies, South America Andes, these are called cordillera. In cordillera, there are 3 ranges: Cordillera Oriental, Cordillera Central and Cordillera Occidental. So, Rockies is also an example of mountain chain. Andes is also mountain chain having 3 ranges. Now let us come to know what is mountain system. System is a vast term. System means, suppose on the earth there were 4 mountain orogeny: Precambrian orogeny, Caledonian orogeny, Hercynian orogeny and Alpine orogeny. We will be seeing these 4 phases of mountain orogeny on a separate world map. But here, during Alpine period, means today, latest occurrence of mountain orogeny, several mountains came into existence. Like at the same time, in this phase, in India, Himalayas was rising, in North America Rockies, in South America Andes, and a number of mountain chains were rising at a time. So these collectively are called mountain system. So these are the terms which you should keep in mind in respect to the topographic or relief features on the surface of the earth. Here is one term, scarp. If the plateau has a steep slope, vertical slope, this is called a scarp, and a small part is scarp, while its long lineament is called escarpment. Its very good example is in India to the west of the Deccan Plateau, that is Western Ghat. Western Ghat is a relief having very steep slope, and just at its foothill or foot plateau, the plain means western coastal plain starts, and sometimes the people living on the west coast plain of India call this scarp as mountain, West Ghat mountain. Virtually, West Ghat mountain is not mountain, rather a steep scarp of peninsular plateau land. So, these are the plain, plateau and mountains. Now, let us see the 4 phases of mountain orogeny in world. There are 4 phases of mountain orogeny on the earth. The first phase is Precambrian. During Precambrian, a number of mountains came into existence. Second phase, Caledonian, several mountains formed. Third phase, Hercynian, a number of mountains came into existence. And the last phase, that is the present going on phase, is Alpine. So, the Mother Earth has given birth to a number of mountains, very high peaks, in 4 stages. Like some animal, maybe pig, maybe cat, gives birth to babies in 4 stages, and in 1 stage, a number of babies are formed. In the beginning, in their childhood, they are together, but at their youth and mature stage, they are separated. In the same way, the earth yielded mountains in 4 stages. First stage is Precambrian orogeny, in which these mountains were formed. Mountains in the north part. Why? It will be discussed in plate tectonic. But here, this is Laurentides or Laurentian near St. Lawrence River along the border of Canada and USA. Likewise, other mountains are here, Allegheny and Killarney. Both are folded mountains. All these 3 are folded. Rather to say, all these are folded mountains, not volcanic, not faulted. So, these 4 mountains are found here in the northeast part of USA. At the same time, during Precambrian orogeny, here Anglesey mountain in Scotland came into existence. At the same time, in Norway and Sweden, or in northwest Europe, Finno-Scandinavian mountains came into existence. If you observe minutely the position of these mountains, it shows that at the time of birth, they were together as the small babies of pig. But at youthful stage, they got separated. Why? Having the same structure, born in the same period, having the uniform geological structure, why they are separate today? Now its answer is very much clear, and it was discussed by Alfred Wegener, and recent years plate tectonic throws very scientific light on the separation of these mountains of the same period. Now, Caledonian mountain orogeny. Caledonia is a mountain here in UK, Great Britain, and especially Scotland. When this mountain was under formation, at the same time here Appalachian mountain came into existence. Brazilides or Brazilian highland was also formed, and at the same time in India Aravalli was formed. Aravalli started originating at the end of Precambrian age and at the beginning of Caledonian phase. That's why the last formations are of Caledonian. Hence, some geologists list it in Precambrian while most in Cambrian period. Now the third phase of mountain origin is Hercynian. Hercynian is named after a mountain in Harz. Harz mountain is located in Germany. At the time of Harz mountain, there are a number of mountains like Vosges, Black Forest, and here Ural between Europe and Asia, here Altai, Tian Shan, Nanshan, Khingan. A number of mountain ranges came into existence this way, this one. Now, the last phase of mountain orogeny means folding occurred in alpine orogeny, which is also called tertiary orogeny, that is still going on, means these mountains are still rising. Among those, Himalayas is very important that we will study in detail, but here these mountains are found in a line. This line starts from Himalayan mountain, then Suleiman, Kirthar, Hindu Kush, Zagros, and here Apennine, Pyrenees, Atlas also. So these mountains, if you observe minutely and close your eyes and see the past, you will see that this was an ocean, Tethys Ocean. Out of Tethys Ocean, most of the alpine orogenic mountains came into existence, as you have seen, list and their lineament, when this was originating due to the northward movement of African plate and mostly Indian plate. At the same time, here Rockies and Andes mountains were also formed. Of the same period, alpine age, same age rocks. Why Rockies and Andes were originating? Its answer will be given by the plate tectonic, means North American plate and South American plate started moving west, while East Pacific plate was moving east. Due to collision and compressional force exerted on the sediment between the two plates, Rockies and Andes mountain system, mountain chain and mountain range came into existence. And here is description of Alps, because Alps mountain is very important in Europe, situated in a number of countries. In the same way, Jura mountain, Switzerland, after which Jurassic time is being named. Here is one mountain called Great Dividing Range. It is also of alpine orogeny, because as Indian plate moved north and Himalayan orogeny was taking place, at the same time this Australian plate moved northeastward and Great Dividing Range came into existence. Thus, if you keep this map in mind and the sequence of these mountains, then you will be able to answer the sequence of mountain asked in question. Second, you can locate different mountains on the map of the world.